Hello everyone. Today we'll see what is the boundary for a MOSFET to known as long channel device or short channel device, and so is there any clear boundary for long channel or short channel? So we will try to figure out that. It's one of the doubt usually we as a fresher gets that how much length we should take to consider as a square law, since a square law is valid for only longer channel. In shorter channel we don't see square law. So let's analyze our MOSFETs. So I have created a schematic. uh, so you can also create schematic like this, and then uh, how to create this schematic you can refer my past videos. Okay, so now launch ADL. So you will get a window like this, and so right click, copy from cell view here. Okay, so and choose any length. Suppose I am choosing 500 nanometer, and VDS is 500 millivolt. VGS is 700 millivolt. Okay, now go to the setup, model library, select TT corner, and then choose analysis, DC, save operating point, design variable. So we will plot GM versus VGS curve to decide our channel length is short channel length or long channel length. So we will shift VGS. So select VGS. Okay, and I'm taking linear sweep. So start from 0 to, you can take any value. I'm taking full range 3 volt, 3, 4, 5, anything you can choose. Step size I'm taking 100 millivolt. Yeah. So now I want to be plotted my outputs. Okay. So first I want to be set my select operating point. Click NMOS and PMOS. Go to the ADL window. Now here you can see uh, we are saving NMOS and PMOS operating point. So here you can click get from simulation. Wait for some time. Okay, now here I want GM. You can select any value. Okay, so I am choosing GM. For PMOS also I am choosing GM. Okay, I want curve. So now run the simulation. Now go to the ADL window. Now here you can see a plot option. Now see, we have got for this operating point we have got GM for both NMOS and PMOS. So, but we want to see GM with respect to length. So choose parametric analysis. Now add variable length from my technology 45 nanometer. So minimum is 45 nanometer, and I'll go up to the suppose 3 micrometer. Okay. Now I want, if you want to include some particular points, you can include. So I am including 45 nanometer space, Suppose 100 nanometer space, 200. Okay, now 500, 800, 1 micro space. Uh, Keep giving the value after giving one space. Okay, 1.5 micro, 2 micro, 2.5 micro, and 3 micro. Okay, now run the simulation. Okay, now simulation has been done. Now go to the file, this one, and reload all sum window. To split this one. Okay, and move to the new window. Okay, now see, we know that in a square law, for constant W by L ratio, GM will be proportional to VGS minus VTH. Okay, so here you can see that I have taken, let me show. I have taken here total width is 10 L. Okay, and my length is L. So my W by L is 10. It's a constant for every simulation. Now go to the graph. Now, so my W by L is constant, and I know for constant W by L, my GM is proportional to overdrive voltage. Okay, VGS minus VTS. So it should be linearly dependent. But you can see here, this is for 45 nanometer. My GM is not some linear, and after that it's getting somewhat of saturated. Okay, it's getting saturated. For this also, it's going to be saturated. Okay, for the this region. So after seeing each graphs and some not clearly, but you can somewhat decide that up to what length it's getting proportional. Okay, here also somewhat mi length GM is going to down, and here 500. Now we can check for this 45 nanometer technology that at 500 nanometer of channel length, my GM is somewhat linearly dependent on VGS. Okay, after more than 500 nanometer, it's following the square law. Okay, so it's a, there will be never a clear boundary for short channel or long channel, but for our calculation purpose and for our square law, since we try to calculate VTH and process parameter using square law, so we always have a doubt like what should I choose length for my NMOS and PMOS. So for 45 nanometer technology, I will take as 500 nanometer as a length to calculate VTH and muon Cox from square law. Okay, so in your suppose you have 180 nanometer, so similarly you can check. Okay, uh, you can check also of 180 nanometer. Generally in 180 nanometer we don't see uh, channel length, short channel effect, and longer channel effect. So you can plot GM versus VGS curve, or you can also plot GM versus ID. Okay, and it will be proportional to root ID. Okay, so you can decide by that also. So for my technology, it will be 500 nanometer. Okay, so thank you. If you want any particular video on cadence, please tell me. I'll try to make. Okay.